Awesome. So we're kicking off now?
Yep.
Okay. 11:02. Cool. 45 minutes. Let's make this happen. So, thanks for coming. Out of interest, how many of you saw my talk from yesterday? Okay. All right, most, which is good. I will be recapping some of the stuff today, but with a slightly different angle on it though, okay? So yeah, please forgive me, and put your hands up if I'm going too slow or boring you. Let me know before you fall asleep. Today I want to talk about CI/CD at some scale, right? And when I say some scale, that's a very good question, but you guys already know who I am, or most of you already know who I am because you raised your hands. I'm Pat. I'm a development manager at Coolblue, a e-commerce retailer in the Netherlands. Okay. I've been coding for a long time. I am a developer still in my spare time, a father and husband, and yeah, like I said, currently based in the Netherlands. What is Coolblue? Because I'm delivering it to this audience, you guys wouldn't have heard of this brand before. Basically, we're a big online and offline retailer in the Netherlands. Think of it like a regionalized Amazon with an obsessive focus on customer service, but I'll come back to that later in the talk. I'm a member of the development department, right? I joined when we were, 40 odd people a few years ago now, and we've grown and grown and grown since then. It's been a pretty crazy ride. So when I'm talking about CI and CD at some scale, or before I talk about CI/CD at some scale, the reason that we have the reason that we've grown so significantly is because we have this focus on customer service or customer satisfaction, and so we want to make sure that we're achieving that, right? So development is scaled along with the making customers happy and making revenue. Sorry, I'm still a little bit jet lagged, I think. So today we're going to talk about, now I'm into the talk. Today we're going to talk about some scale. And when I say some scale, I'm talking about this sort of scale. All right? For us, this was the last day when I was in the office. I went into our Team City just towards the end of the day and grabbed some stats out of it. We've got 3,500 builds that have gone through Team City on that day. These are the stats that I grabbed. So down here is probably the important part for today. This is the context that I'm talking about. Roughly, we do about 70,000 builds a month. And by build, each build should, or most builds result in a deployment. Some obviously don't because you've got all sorts of tests and acceptance criteria in there. But this is the sort of numbers that we're talking about, okay? This sounds impressive though, but it's only roughly for us 19 automated builds per active developer per working day, okay? Now 19 is still a big number, please don't get me wrong, but I'm not talking Microsoft scale, and I'm not talking little web shop, 5 guys pumping out 70,000 builds. We do have quite a large department, nearly 300 developers now, and so yeah, it kind of boils down to each developer pushing out or generating about 19 builds a day on average. How do we do that? We do that via contracts. Right? Those of you that were in my talk yesterday know that the biggest contract or the best contract, the best example that I've got of this is the build PS1. The very important step in making sure that a build runs is having a build PS1 for us. And the opportunity to reach these sorts of numbers as I was going through the story yesterday is because we've had to split out the development responsibility and the infrastructure responsibility. So the development teams choose their tooling. They've got all this tooling to choose from. These are some of the ones that we're currently using. Obviously, there's a bunch of others. I'll go into that in a minute. And our infrastructure team are also making their choices, and they can do that separately, right? That's a very key part of the story that I had yesterday, and a little bit on the story that I have today, okay? So the having that very clean separation, that agreed upon contract, is very important for us. Yesterday I demoed that, we're moving into MyGet or into AppFair for some of these and experimenting there. The development teams didn't notice these stats, the stuff that's running in AppFair, aren't included in the build counter though that I showed you at the start. So that's why I said it's probably roughly 70,000, could be 80, could be 90. We're starting to move some projects over into AppFair. And that sounds awesome, right? Some of you guys, when I was saying 70,000 builds a month, you were like, wow, quick, I got to take a photo. That's the pretty impressive scale. What's the problem with this? Sounds like you've got it all solved. Well, if we had it all solved, I wouldn't have a fun story to tell you today. The biggest problem with this is this one. We have a whole bunch of builds going through the server. How many of you noticed this number though? 3,000 builds, 3,000 configurations, right? This is roughly, each repository has at least 2 configurations. You've got one for your pull request verification and one for your deployment pipeline, right? But even still, this is a really, really large number for us, especially when you're talking about this one. For those of you that came yesterday, you'll know that these guys, if they have to manage, 3,000-ish, different configurations with different sorts of values, even if they're templated, that's still a large number, okay? You've got to make sure that everyone's conforming to the templates, that the templates are satisfying a lot of people, and even though they're templated, you've still got a relatively large number of templates to satisfy 3,000 configurations. The problem is, obviously, because of our growth, and those of you that were here and heard me tell this story, you don't need me to tell you again, but it looked to us like in the very short term, in the very near future, in a very short while, we would end up in this sort of situation where that team was just overloaded, even with the configuration, even with the improvements that we've made, okay? So what I'm here to show you today is some fun stuff. How we, some of the development teams, solved or took some of the burden off those guys, okay? And then hopefully give you guys some takeaways. The easiest cop-out from the solution is automation, right? How many of you were here for the keynote yesterday with Jeffrey? Yeah, pretty amazing story he had. And he said, automation. You automate all the things. And I completely agree, but unfortunately some of our automation doesn't always look the most polished, right? Sometimes we end up with quite some hacky solutions. Especially when you're talking about these solutions being driven by development teams and their autonomy, their ability to make choices about development tooling, sometimes this automation can get quite out of hand, okay? So these are the 2 that I'm going to be talking about today. Cake build. How many of you have used Cake? No? 1? Awesome. Thanks, Matty. This is my colleague, Matt, in the front row. So he's here to provide all the standard answers. Cake build is a very .NET-centric thing, but basically it integrates very, very well with PowerShell to allow you to define build configurations. I'll give you some examples, a little bit of a demo later today. And of course, come on. How many of you have used PowerShell? Yeah, come on. I expected to see all your hands. All right. Yeah, I mentioned that we had the development tooling and we have the infrastructure tooling. Today I'm going to be focused a bit more on TeamCity rather than the other 2, Scrutinizer and AppVeyor. So yeah, that's kind of the tooling, the story that I'm going to be talking about today, or the examples that I'm going to use today. Okay. And some of you, when you see what I'm going to demo, will say, why don't you just, right? Why don't you just use any of these? And the punchline for that joke I already used up yesterday, and it's, I don't know, right? These are the toolings we have. These are the toolings that we're used to. This is what we've already got installed and configured. So it depends. It depends on what our use case is. It depends on what they offer that our current tooling doesn't, all right? The standard answers in IT, it depends, you ain't gonna need it, keep it simple, right? We've already got a big investment in TeamCity and our PowerShell tooling and our Cake build stuff that I'll go over. So yeah, maybe we won't need it, all right, until there's some killer feature. For me, this was reinforced yesterday, and this is a very hacky recreation of Jeffrey's slide from yesterday, where he demonstrated the other Moore's law. That was this one. Where, yeah, you've got your core business, and our core business is making customers happy, right? So our mission critical core business is making people smile. Anything for a smile. That's why that slide is right up the front. That's why I keep on repeating it. I even need to tell our development team, sorry guys, our core mission, our mission critical core context is making customers happy, right? And sometimes developers don't want to hear that they're not core to making customers happy, but that's the truth of the matter, right? Don't get me wrong though, I would argue, yeah, so everything for a smile is the core, and then this is the automate that I was joking about before. So I would argue that this is where we belong, right? As developers in Coolblue, working with these sorts of automation, making these sorts of decisions, we are mission critical to making the customer happy, but we're contextual, right? We're not the core business Coolblue, and I think some of you guys are nodding. Some of you guys might be in businesses where tech is not the core business, but it is mission critical to achieving the core business, and that's the same for us, okay? So, I'm going to go over these 3 tools. That's why we haven't moved to, that's why I'm not going to be demoing Azure DevOps. That's why I'm not going to be demoing the code deploy, the AWS offering. I'm happy that the Amazon guys aren't in here today. So yeah, that's why I've got these tools. That's why I'm going to be demoing this stuff, okay? Specifically, obviously, for your benefit, I'm going to be focusing on PowerShell, all right? What we've done in PowerShell to make it a little bit easier. And because I'm a developer, this is what I do. I've got some .NET Core because sometimes PowerShell was a little bit too confusing for me. So you'll have to forgive me for that one, but I'll take you along on the journey with me, and hopefully it's quite clear for you. How many of you have worked with .NET Core or C# before? A few? Okay, cool. It's all right. It's pretty straightforward. You'll probably see similarities to PowerShell. And before you come up to me after, I know that the stuff that I've done in .NET you could have done in PowerShell, but for me it was a bit too complex. So for me it was cleaner and easier to put it into .NET Core. So, demo time. And this is where I got to at a very early hour of the morning this morning when I was doing my dry run, and realized that my containers aren't in a very good place. I have all this infrastructure set up on my local machine to demo it for you today because I don't rely on the internet when I'm doing these sorts of demos. And unfortunately, there's been a few image updates to the Microsoft images, and those are quite sizable. So I don't actually have to give you a spoiler alert, and I'm not going to be offended if you leave, I don't actually have a working version to demo to you today like I wanted to, okay? I will show you the scripts. I'll step through it with you. We can talk about what would have happened, and you guys please interrupt and question, ask me all sorts of stuff, but I won't actually be able to show you it running, all right? So there's a demo, but it's kind of not really a demo. I'm not going to be able to go like 0.0 build and go. So before we get started, I wanted to show you tell you what I'm going to show you. Basically, I've written some small .NET Core apps, one for our TeamCity API integration. Again, you can use the same TeamCity API from PowerShell, but it's a little bit complex, and you'll see that when we get into the code. Same with Octopus Deploy. Their API is a lot simpler, but it was much easier just to grab their NuGet package from the NuGet feed and pull that into a .NET Core app and write a small integration around that, and then call out to it. Then I'm going to jump into PowerShell, and this is basically we're going to create a project in TeamCity using the .NET app. We're going to create a repo in GitHub by invoking the REST method. That's the guts of it. We're going to create a project in Octopus Deploy, again, calling the other .NET app, and then we're going to create a first commit to GitHub. All right? And the idea behind all of this is that this is an application, a very small application, self-contained PowerShell script, hacky thing, that a developer can pull down and run. And if everything's configured right, and you're relying on production infrastructure as opposed to weird Docker containers on your local, then your first pull request will start building by the time that PowerShell script finishes, right? You'll have a proper build pipeline. You'll have a TeamCity project. You'll have a GitHub repository created for you. You'll have an Octopus Deploy project ready for the artifact to land in. And we're going to use Git via PowerShell to make your first commit and then push that into a PR, okay? And then the idea would be that you'd see a nice green tick in the PR on GitHub. but unfortunately I won't be able to show you that bit today. So hypothetically, I had to add that part this morning, regrettably, but hypothetically, this would mean that all your PR checks would then run on the production infrastructure. Okay? So, you've had enough of me talking. You probably want to see the code. Before I get into the takeaways, let me jump out here. I will close some of this. Sorry, should have get started. So basically, I have is that font size okay with you guys? A little bit bigger? How about something like this? Yeah? Is that good? Cool. So basically, this is where it all starts. For me, I call 00 create all, and I pass in a repository name. What do I want my repo to be called? And a project name. What do I want my project to be called? And then, is this a local demo? So for me, I'll jump into Docker, and do I need to rebuild Docker? Because sometimes the containers get a little bit screwy, and you just want to use Docker Compose, make sure that everything's in a healthy state again. So basically, that's what we've got here. If we're doing a local demo, I'll call out to a different script, building my Docker hosts. I'll pull that one up for you now. How many of you have worked with Docker on your local machines? No? Okay. Basically, Docker's really straightforward. You can define a whole bunch of machines based off a whole bunch of infrastructure. It'll go out to the internet, pull down. Let me show you that. So this is my Docker Compose file. We have basically, I need a database and I need a TeamCity server. As an example, for the TeamCity server, it'll pull down this image from the Docker repo and then start that. Imagine it like a virtual machine on my machine. And then I've got some simple things here like this TeamCity server relies on the database and I need to make sure the database is healthy. I need to expose some ports on my local machine. Basically, it was just an easy way for me to emulate our production infrastructure without having to do a VPN into the office at 5 a.m. on a Saturday. Yeah, sorry, for me it's 5 a.m. The volumes, of course, are then mapped so that I can pull out all the artifacts and that sort of stuff. And so the infrastructure that I had planned to show you was a TeamCity server, a TeamCity agent, which is a build agent, the Octopus deploy. So have any of you used Octopus deploy? It's a .NET-centric tool, but I thought maybe PowerShell people may have given it a go when you're trying to produce modules. Basically, Octopus will help us roll out artifacts into production environments. That's probably the easiest way to explain that. And so if I'm running this on my local, we're going to call out to Docker, build up those hosts, use that Docker file, and then recreate it if I need to, and then get going. These 4 steps down here, these 4 invoke expressions, and you'll have to forgive me for my PowerShell. It's not my first language, but I think this stuff that I'm showing you today is clean enough. It's not production quality. This is why I said there's hacky solutions. But we're going to create a TeamCity project, create a GitHub repo, create Octopus deploy, and then create our GitHub contents. So if this worked, if I had my TeamCity infrastructure up and available, I would then run this .NET application, jump in here with the project name, which is, to give you guys a bit more of an idea, this one's probably easier, and I need to change the zoom to a reasonable value for you guys. Is that okay, or a bit bigger? A bit bigger. Okay. You're sitting right up the back, so I'll help you out. So basically here I've got and how many of you have worked with classes in PowerShell, or were in Erwin's session just a few minutes ago? Yeah? Okay. So classes in PowerShell look very similar to classes in C#, surprise, surprise. I wonder where they got the idea from. The basic idea here is that we've got some parameters up the top, some constant strings. We've got a cancellation source token and a progress indicator. Don't worry about those. Those are things that help me to make sure that things are happening and it's not just frozen. It's basically a little console spinner icon. And then we've got some other resources like our auth key, our project name, and the TeamCity connection. So when this .NET Core app starts, I call out to a parser, a console line parser, because other people have done that before and I don't then need to do it myself, and ask it to pass the arguments. How many of you saw what the arguments were coming into this console app? No one? Cool. That's all right. Basically, to call this, we pass in our project name. All right? So the only parameter that I'm getting in here is our project name, and I've also got an auth key specified, but that comes in through a different environment variable. A little bit of magic there, sorry. And then we kick off we assign those to local values inside the class. These are like hidden properties in PowerShell classes. We kick off the cancellation token and the progress indicator in case I want to cancel. That gives me the opportunity to back things out. And then we create the project in TeamCity. Now, this is where I said it gets a little bit easier for me to do this in C# than it is in PowerShell, because the only real proper integration between TeamCity and .NET Core or PowerShell is a Fluent library, which is great. They're marvelous for developing with. Basically, you say, with this connection, I want to connect. So that's the first line, line 61, line 61 up here. I want to connect to this host, and it's defined as localhost because this stuff would have been up and running in a Docker container, okay? And I want to do that as a guest because I turned off security because it was a Docker container. In production, this would be changed. That line there would be changed back to with credentials or with something lifted out of environment variables with some sort of secrets. I then want to grab my projects. So I use the connection that I've defined the line above to get all projects. And then I'm just going to write out to the console, yeah, don't worry, that means that I was now able to connect. All right, so this is just basically open a connection using this configuration. Am I connected? Can I prove that I'm connected by querying all projects? And then dumping that to the command line for me. I then go and use that project name to define a .NET, in this case, project name, and build that project on this line here, 66, in TeamCity itself. So we've got a whole bunch of complex nonsense in the TeamCity API, but basically I need to find the parent project called demo, which is what I've called our template for today, right? So you can imagine that to be your production templates, add a project to that, and then, create it. It'll basically return from that making a call to the API, like an invoke REST request, and then come back and, with the created project. Then I'm going to open a browser tab to that new project so that I can watch the green ticks, right? Again, if this was a running demo, which I'm very sorry it's not, then you would see there on line 70 that we're going to open a browser window and then jump over to the browser window to show you guys that this project was just created. Would have been magical. We then ask you for a few different configuration questions because obviously these templates need some parameters filled into them. So the 3 parameters that I need for the pull request template are what's the solution file name? For those of you that have worked with .NET, you need a solution file. You need a project file. These two are pretty common in larger projects. So your solution file is a combination of multiple projects, and the project file that we're asking for here is basically the one that you want to run on pull requests, so your main project. And of course the GitHub repo name, and we can pass that one in. That's quite straightforward. So that's by the time that exits, we now have a TeamCity configuration pulled off a template belonging to a parent project already attached in just a few lines of code. All right? There's a whole bunch of other beautiful, progress spinners and cancellation tokens and that sort of stuff wrapped around it. But basically by now, we have a TeamCity project, empty and waiting for our first pull request. The next step was to create the GitHub repo. And then, so we start with this one. I'll get rid of the sidebar for you. For this one, we need 2 parameters, our repository name and our project name. They're both mandatory, obviously, but they're the smallest questions that we can get away with at this stage. I have a module that I've written called start URL, which basically does the same as the C# lines in calling out. I can show you that one so that you know that it's not too magic. I import the C# DLL or the system DLL and use the unmanaged type to set the foreground window using some comm magic. Find the project that this is running as, this specific process ID, and then when I open a browser window, so in this case, what I'm going to do is launch a browser window and then want to return back to that browser window, okay? So it's just a little bit of crazy COM logic to switch, to do an Alt-Tab, basically, in Windows. I also add secrets to our environment variables. Another separate little module I've written because I don't like doing demos with secrets littered all through them. It makes the recordings very complex, and it means that I need to go and reset everything again. And I've got to keep on reminding myself not to show you guys what that file looks like. It's basically add environment variable, this name, this value, this name, this value. There's like 10 different environment variables that I need in there. And they come back, so if you see anything in all caps, underscores, snake casing, or whatever, these that aren't defined, these are our secrets, all right? These are the things that I didn't want to show you today, and you'll need to slot that in for yourself. But basically, we then have three, thankfully, the GitHub repo is really straightforward. We have 3 URLs that we're going to be calling today: create a repo, update the repo, and then add a hook to it, all right? We have some GitHub authentication that we need to take care of as well. We have a headers property, which for those of you that have worked with the, you got a question? I can help. No? All right. So each REST request that needs to go out to GitHub needs to have some sort of authentication. The easiest way to do that is via the basic authentication with the base64 encoded token. There are proper other ways to do it. Like I said, this is a hacky automation. This works for the purposes of the demo today. And then, of course, on these REST requests, invoking REST requests, you want to send out a body with it so that GitHub knows what you're talking about, all right? And this is basically the structure of the, if you followed the GitHub API documentation, the name of the repository, the description that you want to give it, which for me, I just use the project name again. Is it private? So for us, these are internal private repositories, so by default, we set that to true. Do we have issues, wikis, downloads? No, because we turn those off. We have different integration pieces, different tooling at Coolblue for that. And do I want to automatically initialize the repository if it doesn't exist? Yes, of course I do. Here we're making a repository today. So GitHub, please go off and initialize this for me. I then throw that to JSON because, of course, your REST body needs to be JSON. And invoke a REST request method. Yay, this is really straightforward. How many of you guys have worked with REST requests in PowerShell? Yeah, most people, right? It's pretty, I would say it's pretty common. A pretty common use case for PowerShell. So that gives us back a result. From the result, it's typed, thankfully, which is great. And we can request the HTML URL straight out of that response. So GitHub, in their response, sends you back a 201 created HTTP response with a body that actually gives you the URL back to the repo that they just created for you, which is magical for us for demo purposes, because we can write out to our console that we've just created the repo, and then we can start the URL. So basically, like I said, we can Alt-Tab into our browser, kick off the browser process, and then Alt-Tab over to the browser to show you guys what that looks like, all right? And then it'll show you, if, like I said, if everything was working properly, it would show you a nice GitHub empty repository. All right. Then what we want to do is we want to add TeamCity to the repository. All right. So we've got an empty GitHub repo. We've got an empty TeamCity configuration. Now we want to stitch those two together. And this is the sort of stuff that the hosting and deployment team would have to do manually all the time. Okay. So what we do is we invoke another web request. This time we're going to send out a separate body, and we're going to add our TeamCity API user as a contributor to that repository. This is the line 38 there. And then we were going to step through a pending hooks, which is just a local file that contains the types of hooks that we want to create, basically the two that I was talking about before, the pull request hook and the primary build hook. How many of you guys have worked with those sorts of integrations on GitHub? You've set up webhooks and no? Okay. Basically, if you add those two hooks to your repo and point them to your build object, when you push a commit to GitHub, all right, or you make a pull request, GitHub itself will fire off an action to that URL. So for me, I would ask it to call localhost 8111, which is the local TeamCity that I have here. when I push a commit, go and make a web request to this URL. And that web URL is basically coming back to my local TeamCity and saying, there's been a change in the repository, you need to go and pick that up and read it. So that's what the webhooks are used for. Yeah, there's some basically stepping through and adding those two hooks here, but this is nothing different to the one above. And then we've processed the hooks. So now we have an empty GitHub repo, an empty TeamCity repo, and the GitHub repo is now authed to the TeamCity repo, right? In 60 odd lines of PowerShell with a whole bunch of console write lines and out, all this sort of stuff, right? So there's probably, I don't know, maybe 10 actual lines of code in here. In 10 lines of code, we've actually set up the proper GitHub repo and the TeamCity repo and now stitch those two together, which is awesome. Like I said, you guys, when I asked if you'd use Octopus, you haven't, but basically you can, I'll skip that one for time. You can imagine that we've done that as well. We've gone out, used their API in a .NET Core app because their API is quite simple in the .NET Core app. Used their API to make an empty Octopus deploy project and then wired that one back to TeamCity as well. Okay, so now all of a sudden we've got an empty GitHub. I'm skipping over this one. We've got an empty GitHub repo. We've got a TeamCity configuration, and TeamCity is configured when it's successful to push the result to Octopus deploy, which is like an orchestrator. We then want to go and create our GitHub Contents, which is really straightforward. Basically, I have a project up here. So spoiler alert for you guys, I have a folder up here called Default Web App. All right? In this Default Web App, we have basically the empty guts of a .NET application, right? This is like a kickstart for a development team, right? If you want to go and make a new project, so up here, we have some packages, we have a build info, we have build cake, build PS1, and all this sort of stuff as well. What I'll do in creating the GitHub Contents, you guys have already seen this, the fork URLs, the request URLs, the webhooks. I can skip over all that. Basically, we now start stitching them up. We fork it locally. We clone it to our local machine that this script is running on. We copy the default web app whole folder, so this part on line 28 here. We copy that whole folder over into a new folder named after the repository, and then we step through and we rename everything that maps the default web app name back over onto our new repository name. And that's because for any of you that have worked with C#, there's a lot of references to that name. There's a reason I called it default web app. It gives us an easy string to find. That's not a system namespace or anything like that. We're looking for that string in every file in that folder and replacing it with the new repository name, which is basically what's happening here. Rename all the projects, rename the folders, rename the files. Rename the files, rename the mentions. It does take a lot of time for us to find each of these files and each of the mentions in these files. C# is quite complex in that regard. .NET Core makes things a lot easier, but we're not all delivering .NET Core apps yet. And then we're just basically going to use some command line nonsense to add everything to Git, to make an initial commit, and then to push that to our local cloned repo. Right? Or to push that to our fork of that repo on GitHub. We're then going to build a PR. Now, since I've done this, there is a much, much simpler way to make PRs. This was, up until probably 3 or 4 months ago, the easiest way to make a PR, which is basically this here. Now there's actually, because it's this simple, there's actually a GitHub command line application that you can call instead. So that's a lot easier for you guys. If you're looking to pull GitHub integrations on the command line, please go check that out. But this code is available. This is the way that you used to have to do it. You used to have to find your remote and then manually make the web requests as if you'd press the button in the browser. How are we going for time? Getting quite close. And then what we'll do, so we post all that. We now have a fork of a remote repository that was empty. We've copied all our files over locally. We've renamed everything. We've pushed them up into our fork, right? And then we've made a pull request from our fork into the main repository. And now because we've got the Team City configuration and the Octopus deploy configuration, GitHub will call out to Team City. Team City will start building that first BR for us. That's all it is. Now, I promised you guys yesterday that if you wanted to see the build PS1, right, then I would also show that today, which is why I'm rushing a little bit through this. But for now, what we would normally do after we've created the GitHub contents, and I will get to that, don't worry. But to wrap this one off, by now, after we've done these 4 scripts, which take literally 60 seconds to run, we have a brand new Team City configuration, a brand new empty Octopus deploy configuration, a brand new GitHub repo, a locally copied version of the default web app that we happen to have sitting locally is now up there, and we've got a pull request, and Team City by now should be picking up that pull request from GitHub itself and building that for us, which is why I have the agent and all the rest of that stuff in the Docker file. Okay? Do you guys have any questions about that infrastructure or how we got that up and running? No? Cool. So, because there was so much interest in Build PS1 yesterday, I happen to have one here. If we look at our default web app that we copy everything over into, I've put a default Build PS1 in here as well. Okay? How many of you, when I asked you before how many of you have worked with Cake, most of you said never, or most of you didn't put your name up, your hand up, and that's fine. Basically, this is the Cake build default PowerShell script file. All right, this forms the guts of our build PS1. We've got a whole bunch of documentation in here about what target to run, what configuration, verbosity, all this sort of stuff. Is it a dry run? I now know, after attending this conference and having a chat with some of the speakers last night, that there are a lot easier ways to achieve this, so maybe I'll make a PR back into the Cake project itself. To enable things like verbosity and dry run instead, using the built-in PowerShell stuff instead of configuring it ourselves. We have a commandlet binding here with a whole bunch of parameters that we're going to pass into our build PS1, or a whole bunch of parameters that could be passed in. Most of them don't need to be changed from the defaults. There's only a few here that I would say are core for us, which is the verbosity. If you're having trouble, you can change that from normal to diagnostic, or from normal to quiet, depending on your use case. And the skip Cake verification can also come in handy for us. So Cake, without going too deep into it, Cake does some verification that all your build numbers line up, and that your packages are all interoperable, and that the versions all line up. Sometimes you actually want to skip that check, especially when you're doing things like local demos. Now, we try and set PowerShell to use TLS 1.3, I think, by default. But if that fails here, we're actually going to skip the whole process. Basically, for those of you that have worked with security certificates and stuff before, there's a whole bunch of stuff that PowerShell does by default that is now outdated. And there are some PRs to fix this, and there are some new things coming out in PowerShell Core that fix a lot of this and deprecate a whole bunch of the old Cypher suites and that sort of stuff. But unfortunately, yeah, you still need to configure some of this stuff yourself. So basically what we're saying here at the top of all of this is to set the security protocol to something that we would consider appropriate, or something that we want to use. I also have 2 functions here. One is to MD5 hash a file. That's quite simple and straightforward. It's a standard using the cryptography libraries and using a whole bunch of C# stuff, or the using a whole bunch of the .NET framework DLLs or system namespaces. We can MD5 computer hash, and that'll come in handy later. And creating a proxy-enabled web client. Again, using some of the .NET Framework DLLs. Basically, we want a web client to be able to make requests for us that has all sorts of default credentials and that sort of stuff. So these are the handy functions that we will come back to after. Fast running out of time. Basically, we build up a whole bunch of our parameters here, and we're looking for Cake, which is an executable, stored in a tools folder relatively close to the application. I'll make all this available, or these are, I think, already available on GitHub. I can link to them at the end. We want to make sure that our tools folder exists here, so we're testing the path. for the PowerShell script root itself, so is the path that we're operating in still valid, and is the tools directory available from a relative location. If it's not, we will create that directory and then download our tools into it, which is why we needed the Cypher suite updated, which is why we need the proxy-enabled web client, and it's why we needed the MD5 hashing, which you'll see in a second. So now we get our proxy-enabled web client, and we basically use that to download a file. Now, I know there are easier ways, or there are more straightforward ways to do this in PowerShell directly, but at the same time, this one will handle your local credentials, or doing it this way will handle things like your local credentials by default. It will be able to impersonate you and be able to handle proxying and security certificates a lot easier as well. Okay. So we're going to download Cake into, we're going to download our packages config, just a default empty packages config into a location. We also need to find NuGet, which for those of you that have worked with .NET, you know what NuGet is. It's basically a packaging tool. Being able to find packages and pull down those sorts of packages. Imagine it like an apt-get or a yum. For those of you that have come from ops backgrounds, maybe there's equivalents that I can't think of right now, but there are package managers out there all over the place. NuGet is just the .NET Framework version of that. So we add that to our path. We add that to the local tools folder. We will go and download that if it doesn't exist. Thankfully, it's publicly available quite easily. And then, of course, we're going to add that to our environment variable so that we can refer back to it, because it's a lot easier to refer to an environment variable than passing the value around to all the scripts that need NuGet. We're then going to ask NuGet itself to restore all the tools, which is where we see the MD5 hashing come in handy as well, because if those tools haven't been updated recently, then there's no need to go and re-download them, refetch them from NuGet. We're going to write all those tools out to make sure that all the required tools live on disk, and then output a value to the command line. We do the same for add-ins, and we do the same for modules, which are basically, you can think of them as the same thing, especially if you're not an active .NET developer. These modules and add-ins that we have on Cake are quite important for the developers, but not so much for the process. We then make sure that Cake exists, build up our arguments, and then shoot out to it. Basically, here are all the different arguments that this executable is wanting. We build them up using the parameters that were passed into PowerShell, and then we basically call out to Cake using the shortcut, because I'm lazy by the time I got to here. But yeah, we call out to Cake and we pass in all our parameters. That's basically for us what a build PS1 looks like. And then Cake, I can step you through a Cake build project for the C# developers that are out there. You can go and have a look at the Cake, the build.cake files that are already in their repo. The default ones are actually quite well documented and quite straightforward. We have some complexity in ours, but that's probably a bit too much for today. So, do you guys have any questions about that stuff so far? No? Well, then let me finish up, if this comes back. What happened? It must have figured out I was stressed. Hold on one second. Yeah, but it should be cached locally, which is frustrating. And it's giving me a weird cursor. Basically, the takeaways that I wanted to give you guys today, I can quote them off the top of my head. Lean on the tooling that you have available to you. Okay, so today I've shown you some of the tooling that we have and how we've got those integrations. But you need to, lovely. There we go. All the way down to here. We've only got a few slides left. So the key takeaways. Automate all the things. Use the keynote. Use the messages that Jeffrey was giving you, and also Stephen from their keynotes yesterday, to figure out what's core to you and what's contextual to you in the context of mission critical and everything else. don't do anything that's here. Like I said to you, I already put our development teams up here in contextual but mission critical, and that's why it's made some of the decisions that I've shown you today, why I'm doing some PowerShell hackery with Team City instead of moving to something like Azure DevOps or the code deploy stuff on AWS. Lean on the integrations. So I've shown you today that all of the tools that we've used in our production environment have different forms of APIs. Some of them are quite complex, some of them are quite straightforward, but all the tools have APIs. Find the tools that are applicable for you guys, or if you've got tools running in your environments, lean on those APIs, lean on those integrations, see if you can stitch as much together as you can automatically. Don't be scared of using the current tooling, which is a common theme. I see a lot of people jumping on new bandwagons. As your DevOps pipelines was just announced, so, oh, we need to move to that. It makes things easier, yeah, but at what cost? So keep an eye on that. Find the pain points in your environment and remove them. For us, this was the example of the hosting and deployment hub in the talk that I used yesterday. And again, asking them to set up and maintain 3,000 build configurations was definitely a pain point. So replacing it with some hacky PowerShell is probably a bit nicer. A little bit nicer. It was some pretty hacky PowerShell. And reduce friction. So for us, there was a definite friction there between, hey, build guys, can you please set me up a pipeline? And the developer's going, why do I need to wait 2 weeks before I can get a pull request in? That was a very big source of friction for us for a very long time. So for you guys, the biggest takeaway I want to give you is find those pain points in your organization, find those friction points, and see if you can use APIs where it's responsible, where it's applicable, to reduce that. Okay? If you've got questions, come see me in the break. I also want to make sure that you guys get out of here, and I've gone over time. Thank you.